Good morning, good afternoon, good evening. My name is Camilo Rojas from the MIT Media Lab, and I'm happy to share the results of our project Saving Face. The motivation for the project was truly the beginning of the COVID-19 pandemic. Back then, the leading theory was that COVID was being transmitted because of hand-to-face touching. This was a reasonable assumption considering that touching our faces is a universal human behavior. We do it very often, even without realizing. And then, of course, we learned that the airborne transmission was a more significant vector. But we also learned that the hand-to-face touching vector was the key vector for many other pathogens, such as influenza. Now, it was also interesting that we learned that around 100,000 people die every year in hospitals of the US because of infections that they acquire in the hospital. We also learned that there are a number of compulsive behaviors, such as herd pulling, that can be treated if we provide the people with a system that would make them aware the moment when they are touching the face or their head. So this is how Saving Face was born, and we thought that we could create a system that would be able to transform any smartphone and its as a pair of earbuds into a portable sonar system that can basically detect when the hands are approaching the face or the head and can emit a notification to the user. So one of the main challenges that we face was that if we want to keep the system inaudible, because of course we won't like people to use it during the entire day and we don't want to disturb their normal activities, we would need to operate in an extremely narrow band of the operating curve of commercial earsets. So in this case, it is the orange stripe that you see in the plot. Now, the way that we tackle it was to use two complementary techniques, FMCW and Doppler shift. We showed that when we use them together, we were able to extract a significant amount of information correlated with the face touching, as you can see in the bottom right picture signaling two face touches. We ran a user study with 29 subjects, and we showed that when we use the two techniques together, we get a significant increase in the accuracy when detecting face touches. Now, the second challenge that we faced was that if it was necessary to distinguish the distortions in our signals that were related with face touching from the distortions in the signals that are produced by many other activities that users would do in their daily, on a daily basis. So the way that we addressed it was by building a data set and a machine learning model. So we engaged around 29 users from around the world to share the patterns and to use our system when doing a number of activities. And this enables us to build a logistic regression model that can quite accurately detect when the user is touching the face and distinguish it from other activities. So we ran a user study and we showed that the sensitivity and the precision of our system goes over 90%, and also that most users will be willing to use the app in real life. Now, just to recap the conclusions, first we introduced a novel and rapidly scalable approach to behavioral change that can lower the hand-to-face transmission of COVID-19 and other pathogens. Second, we designed the first acoustic-based system to track hand-to-face movements based on FMCW and Doppler shift sonar techniques and machine learning algorithms. Third, we implemented the system in a user-friendly iPhone app, available for anyone that uses a smartphone and a set of commercial earphones. And fourth, we evaluated the system's performance in multiple experimental environments to observe an average sensitivity of 93.7% and precision of 91.5%, as well as an overall positive user experience and adoption intention. Now, going forward in the project, we would love to use this approach of adding new capabilities to existing deployed commercial devices. For example, we could use baby monitors to monitor the breathing and the heart rate of a baby. We could use the sound system of a car to detect when the driver is distracted and sending a nudge so that they become more attentive of the driving task. And we can also use smart TVs to enable the user to control them using on-air gestures. I'd like to thank the wonderful group of people that made this project together. You may find the complete list in the website and the screen. I'll be happy to address any questions you may have.